So let us quickly see how we measure these angles, all right? To measure an angle, you need your protractor. This middle point of the protractor, where the horizontal line of the protractor 0 to 180 met with the 90-degree line. This point, the middle point of the protractor, is very important. Whenever I want to measure any angle, this middle point must be placed at the point where the angle is formed. For example, this emergent angle, which of course is the first one we're going to measure here, this middle point will be placed at this point. Why? Because this angle is formed at this point of emergence. The angle you are measuring is between this normal and this emergent ray. Therefore, the middle of this protractor will be placed at that point where the angle is formed. I hope you take note of what I just said. Now, having known where you're going to place this middle point, the next thing is, where will you place this horizontal? Which line, which of the ray line here would you place this horizontal line of the protractor? Where you place this horizontal line of the protractor is very important. And where do you actually place it? Answer. This 0 to 180 degrees line should be placed to lie on one of the two lines that produce the angle you want to measure. For example, this angle of emergence that I want to measure, okay, if the middle point is placed at this point E, the point of emergence, this 0 to 180 horizontal line of this protractor will be placed either to lie on this emergent ray or to lie on this normal. The choice is yours. But I usually advise that we place the horizontal line to lie on the shorter ray. So in this case, like the normal and this emergent ray formed this emergent angle of emergence. So if you look at the length of the normal and the length of the emergent ray, the normal is shorter than the emergent ray. So for me, just as a suggestion, not a law, I prefer this horizontal line, 0 to 180 degrees line of the protractor, to be placed so as to lie on this normal, which is shorter. The reason is because the one that is longer will usually come out of this edge, okay, this curved side of this protractor, so you can easily see where you are measuring up to. So this is just the technique of measuring your angles, and I'm going to show you some. Let us measure this angle of emergence, E, okay, let's measure it, E. Now this is going to be this way. I will place my middle point of this protractor here. Okay, I'll place it here. Then, like I said, you can see the middle point will be placed here. So let me do that. Like I said, the 0 to 180 degrees line should be placed in such a way that it will be lying on the shorter line of the two lines that formed the angle you want to measure. The angle we want to measure is the angle of emergence. The normal and the emergent ray formed that angle. So I will rotate this thing so that this 0 to 180 degree line will be on this normal line. So this is going to be rotated this way. Okay, it doesn't matter if you are rotating, free yourself. Don't be too rigid, because the middle point can shift. Once you do that, adjust it properly, you can see the middle point is on the point of emergence now. You can see that. Then you adjust your protractor so that this normal will be on this 0 degree. You can see that. I've told you the reason. The normal is now on the horizontal. Watch, the 0 to 180 degrees. You see that the normal came out there. The angle you are measuring is the angle from this emergent ray to the normal, or from the normal to the emergent ray. You can see that. So let us measure the angle, please. That will give you the angle of emergence. From 0, it turns down to the emergent ray came out here, which is 60 degrees. So E is equal to 60 degrees. E is equal to 60 degrees. I have measured the angle of emergence. Remember how you place your protractor, very important. The placement of your protractor in order to measure the required angle as may be asked usually is something that takes students time. And I've shown you the trick. The middle point of the protractor should be placed at the point where the angle formed. Then the horizontal line of the protractor 0 to 180 should be placed on one of the lines that formed the angle. In this case, I placed it on the normal. I usually advise place it the 0 to 180 degrees line. Place it so that it would be on the shorter line out of the two that form the angle you want to measure. Okay, let us move on to this angle. I want to measure the angle of deviation D. The angle of deviation D. That angle of deviation is between the incident ray which I produced and the emergent ray which I produced. You can see that both of them met here. And this is the angle of deviation D. So let us measure it. It means that the middle point of my protractor here will be placed at this point, because this is the point where the angle is found. Then look at these two lines, the incident ray produced and then the emergent ray. You can see that. I'll make sure that the 0 to 180 horizontal line of the protractor is placed on one of these two lines. Look at the incident ray produced, then the emergent ray. If you look at this, the incident ray is shorter at this point. The emergent ray is longer. So once again, I will place the middle point of my protractor where this angle is being formed, was being formed. I will place the middle point of my protractor where this angle is being formed, this point. Then my horizontal line of the protractor, I will place it on this incident ray produced. And that would be something like this. I think I've gotten the middle point. I will now adjust the protractor. Look at the horizontal side of the protractor, the 0 to 180 degrees line of the protractor will lie on this incident ray that is being produced. So we have something like this. You must make sure you avoid error of parallax, so you look directly down so that you don't make any mistake. Good. I think I've gotten that. Correct. You can see the incident ray moving from here through this 180 or 0 degrees line. Good. Then the middle point is at the point where the angle of deviation is being formed. The angle of deviation is the angle between the incident ray which you placed at this 0 to 180 degrees line, from there down to this emergent ray. That is from here to this point. Already take note, this is the point or the line where the incident ray will come out, because I placed this horizontal line of the protractor 0 to 180 degrees on the incident ray. So from that incident ray to the emergent ray, that angle is the angle of deviation. So we check. From here, 0 degrees, it moves down to this place. From what I'm seeing, it is 40 degrees. So angle of deviation D is 40 degrees. And that, I decide to record here, D equal to 40 degrees. I've measured E, let me record it here. E equal to, I think we got that to be 60 degrees. Good, I've shown you how you measure this angle of deviation. Let me show you another angle of interest that you might be asked to measure, the angle of refraction. This angle here. The angle between the refracted ray, the ray refracted inside the glass after the incident ray hits the glass at the point of incidence. The line that connected this incident point to the point of emergence is your refracted ray. The angle between that ray and this normal at point I, this normal, look at this normal that is produced inside. The angle between the normal and the refracted ray is the angle we call the angle of refraction. Now how do we get it? Once again, this is the point where the angle formed. You can see these two lines, the normal and the refracted ray. So the middle point of my protractor will be placed at the point of incident where the angle of refraction formed. Then this 0 to 180 degrees line will be placed on one of the two lines that formed the angle of refraction. So my 0 to 180 degrees, the horizontal line of my protractor will be placed on one of the two lines. So for this reason, I would prefer to extend. Let me see if I can extend this normal more so that I will measure to it. Okay, so I'm extending it, something like this. I can always clean off my excesses. my excess line can always be cleaned off. So we go. I want my 0 to 180 degrees line to lie or to be placed on this shorter refracted ray. Then the middle point of my protractor at this point. Then I'll measure this way. So we're going to have something like this. I will adjust the protractor. You can see I'm turning it. Now I have overturned the protractor. You can see that this is a refracted ray. The 0 to 180 degrees line of the protractor is not on it. So I've got to go back. Good. I think it's on 8 now. Always look directly down to avoid error of parallax. Look at 90 degrees down to what you want to get. Okay, so it is perfectly on lead now. It simply means that this horizontal line of the protractor which came out is now representing my refracted ray. Measure from that point down to your normal that I extended here so that I'll be seeing it clearly. From here to this point, from these 0 degrees to this point is my angle of refraction. So all I have to do is to measure and record it. This is 0 to this 10 and then down to this place. Watch, this is 20 already, 20 degrees. But the angle is beyond 20 degrees. Coming here, I think it's on 22 degrees. 22 degrees. So that is my angle of refraction. I'll record it, R equal to 22 degrees. R equal to 22 degrees. Good. So you see, you can be asked to measure any angle. There are many angles here. In fact, I would like to measure this one lastly. But I'm happy that somehow, some way, you've understood how to place your protractor in order to measure your angle. Very important. We must not measure all the angles here. I'm trying to measure the ones of extreme importance that you might be asked to measure. So I'd like to measure this angle here. Let's see what the value is. Okay? So how do you place your protractor? Once again, the middle point of the protractor would be at this point where the angle formed. Now the two lines that form this angle are the normal from the point of incidence and the normal from the point of emergence. These two lines. So I'm going to place my protractor, the middle point, at this point where the angle is formed, and then the horizontal line of the protractor on one of the two normals. Okay? I would like to use this normal. So I'll place my horizontal line of my protractor on this normal so that I will measure towards this normal. This is the angle of interest. Look at the angle between these two normals. So we go, the middle point of my protractor is now at the point where the angle is being formed. I would have to rotate my protractor. Now watch, if I rotate my protractor and it is lying this way, something like this, I will be in trouble. Yes, because the angle that I want to measure, the angle is not this way. The angle is this way. The angle between these two normal. So if I place my protractor this way, I need to rotate my protractor to go like this. So watch, this is the perfect position you should be in terms of how to measure. Then you adjust your horizontal 0 to 180 degrees line to lie on one of these normal. And I told you I want to use this normal. So the protractor will turn this way, turn this way. Good. You can see that this normal, okay, let me adjust more. Good. This normal is now on the 0 or 180 degrees line, which is the horizontal line of the protractor. You can see that. Then my middle point is here. I'm measuring the angle between this normal and this one. So this angle, that's what I'm measuring. You don't need to draw this curve I'm drawing. I'm just doing that to show you what exactly I'm measuring. So taking here to be 0, if you move this way, you take it to be 180, you move it this way, this is where the thing came to. Are you following, right? So we see, okay, let's see. Good, I've placed it. So this is from 180 down to 70, down to 65, then close to 60, but it's not on 60 exactly. If I think from what I'm seeing here, this would be there about 65. This is 60, 61. right? So let's say, let me use this measurement from 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. This 110 is up to 70. So 110, 115, 116, 117, 118. So the thing actually came out at 118 degrees. 118 degrees. That is the angle here, 118 degrees. Okay? So whatever you label this angle is going to be 118 degrees. Permit me please to label the angle as, let's say, A prime. A prime. So that A prime is 118 degrees. 118 degrees. Good. So I want to believe that you've actually understood how to measure various angles there. Can we quickly measure this angle here? This angle, because there is a name given to that angle. It's called the refracting angle of the prism. So let us see how we measure this angle. That angle is formed at this point between these two lines of the prism. So I'm going to place my protractor at that middle point, rotate it so that the horizontal line will lie on one of this side of the prism. Get something like this. Good. Then you will measure to the other side of the triangle. Unfortunately, I did not produce it, but I'd like you to watch. The angle I want to measure is from this point, this horizontal, you can see it, down to this line. Look at the line. So if you follow the line and you come out, you are going to get, good, it came out at 120 here. This is where the second side of the prism, this is the point it came out, which is at 120. So measuring from 180 to 120 is 60 degrees. Or you use this measurement 0 to this, you get your 60 degrees. Good. So it means that the refracting angle of the prism I used for this experiment is 60 degrees, which in most cases we expect of our triangular prism, because most of them are equilateral triangle. So these are the ways we measure all these angles and places. Very important to get to know about it. For this experiment, the two angles I am interested in is the angle of emergence and the angle of deviation. Therefore, I'll be interested in E and D. For this angle of incidence of 40 degrees, it produced angle of emergence to be 60 degrees and angle of deviation to be 40 degrees. Alright guys, I hope you enjoyed this experimental demonstration of refraction of light through triangular prism. Alright, I've been able to demonstrate this experiment for you and of course shown you how to measure all the necessary angles. You can take a look. Good. Don't forget especially how to place your protractor when you are measuring your angle. You are interested in the placement of the middle point of your protractor and of course how to place your horizontal. Very important. Alright, so soon I'll be releasing the table of values for all the readings of the incident angle. Remember, the one I demonstrated here is for incident angle I equal to 40 degrees. So for other incident angles, I'm going to show you the table of values soon, and of course with the graph and possible deductions, alright, questions that might be required to answer from the graph. We shall see a graph where we plot the incident angle I against D minus E, that is deviation angle minus the emergent angle, which I showed you how we measure them. We're also going to have a graph where we plot the angle of deviation D against the angle of incidence, where we'll obtain a curve and then get the minimum deviation. Alright, please do like and subscribe to my YouTube channel at GMAETS 41. Turn on the notification bell so that once I upload the video lesson, you will be personally notified. Share my video lessons, share this video particularly because there are many out there that would want to learn something very crucial to them from this video lesson. Don't forget, there are other science courses and engineering courses that you can actually get important educational tips from in this channel, GMAETS 41. I hope to see you in my next video lesson as I analyze the graphical work on this experiment.